What if we hypothesize this, that the population mean is some value mu sub 0 against an alternative hypothesis that it is greater than whatever this value is, mu sub 0. It could be maybe, let's say, 25. Let's just say we think that it's 25. Doesn't matter. Could be any number. Now, when we specify alpha, and say we specify 0.05 this time, then what we are doing is defining the probability that we would commit a type 1 error. Alpha is the probability that we would commit a type 1 error. And what that means then, a type 1 error, is rejecting a true null hypothesis. So alpha is really just the probability that we would reject a true null hypothesis. And we can see that in the picture here, because it is possible that the population mean is 25 or whatever we specify it might be, and we could still land up in here in this rejection region because there is some area up in here if this is the actual distribution of the variable. So it's possible that we could reject a true null hypothesis. But what if we were to hypothesize what we have here when actually the population mean is some other value, mu sub 1? And, let's just say that it might be 30 or something. Could be anything. But clearly we can see it's bigger than mu 0 here. We've got it moved over here to the right. Okay, well, this is a right tail test. And if we think about this for a second, if we actually have a z value, and let's just say we're using z here as our distribution. If we have a z value that's here at some value, some x value, and we were to project that to this other situation here, same x value, but this x value, if we move the mean to the right, which that implies something that isn't quite correct because the population mean is not variable, it is fixed. But if the actual population mean is over here to the right of where we thought it was, then that same x value is closer to that actual population mean, which puts more area up here. Now, this area is called the power. And the power is the probability of correctly rejecting the null hypothesis. Now, we are typically only interested in the power when the null hypothesis is actually false. Now, alpha is the probability of committing a type 1 error. Beta is the probability of committing a type 2 error. Now, what is a type 2 error? A type 2 error occurs when we fail to reject a false null hypothesis. Now that then would be this area over here. If the null hypothesis states that the mean is, say, 25, but the actual population mean is 30, we could land back in this region back here and not reject the null hypothesis. So we would be committing a type 2 error. And what we can see then is that beta is the complement of the power. So in other words, beta plus the power would be equal to 1.